Hi everyone, I am Anu and welcome to AI Ki Pathshala. Today we are going to discuss in details about the bitwise operator. We will study the complete background of how the bitwise operator actually works and everything related to it. So I'm opening my, sharing you my sheet so that we can start our discussion. Is my whiteboard visible to you?
Yes.
Fine. And am I visible right now or not?
Yes, you
No.
are on the
I'm
top.
not visible. I'm on the top, but am I visible at your end? Am
Yes,
I
you are
visible
visible
to
on the
you?
top. You are visible on the top.
Okay, I'm visible on the top. Huh? What about now?
No, still you are visible. Doesn't matter, you are visible, that's okay.
Okay, fine. So let's first understand this. Let me first tell you. Computers store all kind of information only in the form of 0 and 1. This is called 0 bit. This is called in terms of computer, it is these two are called bits, 0 and 1. Computer only understand the language of bit language. It doesn't understand anything else. Whatever we write, whatever number, let's say this number, or whatever text we write, let's say this is a text, or whatever image, or whatever video, or any data, any form of data that we have, what computer do, it finally converts this into this binary form, into the binary form. Binary form means 0 and in the form of 0 and 1. Then after that, it is able to understand what this data is. And it performs its processing, whatever we ask our program or whatever we ask computer to perform the process, it performs that process and returns us the value in the form of 0 and 1, only in the form of 0 and 1. Whatever value it returns us, it is only in the form of 0 and 1. And thereafter, there is an interpreter which converts this binary value into decimal value or some other value into decimal value, and thereafter it gets converted into other forms like maybe text form, maybe video form, maybe image form, or any other form. So this is how the whole chain works. So what Python bitwise operator do? What Python bitwise operator do? Python bitwise operator basically works on the either on the 0 and 1. There are certain like operations that we are going to study in the bitwise operator. So it performs all its tasks at a bitwise, at this level, at a very granular level. It is called granular level. Granular level. Granular level means at a very deep level. Whenever whatever data we put, it gets converted into first in some form, then finally into decimal form, and after decimal form, it gets converted into binary form, and thereafter, computer is able to understand what this data is. Hope this is clear to you. So,
Yeah.
Yes.
next page, where shall I generate the next bit? This page 1 and page. I will be sharing you this page with you. So, page. So, in the morning, this I have already explained you about this operator, bitwise operator. Now there comes two things. One is called oh, so there is two operators. One is called unary, unary operator. Another is called binary. It's called binary. Whenever we do bitwise operation, we will. This is called. See, we have understand this. Let's say A or B. So what A is? A is called operand, and B is also called operand, and odd is called operator, bitwise operator. So usually when we do the bitwise operation, we usually do it either on the binary operator. Binary means 2. Let's say A and this is B. So binary means 2. Whenever this bitwise operation will take place, it will either take place in binary way. What binary way means, one operand will be in the left, other operand will be on the right, and there will be some operator in between, like or, and, or not, XOR, or something else. Unary means only single operand is there. When there is only single operator, operand, that is called unary. Let's take an example of unary operator. If I am performing this operation, what is this operation? This is not. I think you are aware of this. This is, I think, not operator. So here we are not
seeing
performing
any
the.
change.
You are not see. You are not seeing anything.
No, we are seeing, but your cursor is not visible.
Okay. Okay. My whiteboard is visible, na? Okay. See what I am telling you. Have you understand this binary?
Yeah. Binary we understood, and I think
Unary means only operation will
okay.
be taking place only on single operand.
Achha, now it's
Okay.
okay. Now it's visible. You're going down now.
Okay. So unary means operation will be taking on only on the single operand. Binary means the operation will be taking place on two operands. One operand will be on the left, other operand will be on the right, and there whatever operation we will perform, that operator will be in the middle. But in the unary operator, there is only one operand. One example of this is the not. If I say not A, I do not need two operand here. I only need one operand. If I want to take the value of not A, here there is not a requirement of two operand. Only single operand is able to give me the value. So this type of operation is called unary operation, and this is called binary.
But there is no change in the whiteboard.
What? There is no change?
Yeah. I think the previous slide is only there.
On the previous slide is there? No. So,
Your cursor is not visible.
Ruchi, are you able to see this? Ruchi,
Yes.
what you are able to see right now on my screen?
Operand.
What is at the top? What is written at the top?
Unary. Binary.
Thereafter,
A or B.
that means my screen is visible because the Ruchi is able to uh, see my screen. So I think there is not any issue from my end, because if Ruchi is able to see that, that means it is fine from my end.
But I don't know. I'm unable to see. I'm seeing only the first slide.
Is in the first one.
Yes, you have gone on the second. Now I am clicking on the second slide, then it is coming.
Yes.
But it should come automatically. Why it is coming to me? I think the command should be in your hand.
Maybe uh, whatever is setting, like, they have asked me to choose something. Maybe I have chosen something wrong. That's why.
Anyway, it's now I'm able to see it.
Okay, fine. So next time when they ask me to choose, I will choose it very carefully, so that you won't face any issue. So is this thing clear to you? This urinary thing and bind this
Once again, can you?
this unary, this binary, A or B, this is operand, this is operator, this not A is an example of unary operator, A
Okay.
or B is an example of binary operator. That I meant. talking about.
Okay.
Okay. So let's move to third page and adding. Now, what you are able to see right now, Mr. Misra,
Urinary, binary,
and will
A or
you
B.
okay. Please go to the third page. I'm sharing the third page right now.
Okay, okay. Okay.
Now the everything is blank here. Real
Yes.
clear crystal.
Yes, yes.
Now let's try to understand one thing. See, 0, 1, 2, 3, 4, 5, 6, 7, 8, and 9. How many total digits are there? How many total digits are there from 0 to 9?
10.
10.
10. So we are all used to using this representation of numbers. Whatever number you will, you can able to form any numerical numbers with the help of these 10 numbers in these 10 digits. Am I correct? Am I correct? You will be able to form any kind of number with the help of these 10 digits. So this form of representation is called, either you can call it numerical representation, or in terms of programming language, we call it decimal representation. Decimal representation. This is just a name, decimal representation. Whatever number you want to form, numerical number, whatever you want to form, with the help of how many digits you will be able to form that number? With the help of, this is a question for you. Am I getting an answer? Whatever number you want to form, how many digits you have in your hand to form that number?
10.
10. Correct. Do you agree, Mr. Bhagwan? Mr. Bhagwan?
10, 10.
Correct. 10. So we call this kind of representation as a decimal representation with a base 10. Do you understand this? Let's say, if instead of this 9 number, if I have some other form of representation of number in which I have only 5 digits, not these digits, any other digit in any other language that you are not aware of that language. If we have 5 digits, so this decimal representation has a base of 10. So that that maybe call it that decimal representation has a base of how much? 5. Do you understand this? Ruchi?
Yes.
Now, I'm moving to next page. So you guys also move to the next page. There is a clear screen. Now, then you have only the option of representing, then you have only the option of representing anything with the help of simply 0 and 1. So how many digits do you have?
2.
Only 2 digits. So this form of representation is having a base of how much? This form of representation is having a base of how much? Mr. Misra, I expect an answer from you, please. Are you able to get my point? Or if you are you having any doubt?
Yeah, once again.
Please wait for the one. Hello.
Yes.
Yes. So have you understood the previous thing? We
Yeah.
have 0 to 9. So we called that it has a base of 10. In the decimal form of representation, I told
Mhm.
you that decimal form of representation, we use number from 0 till 9. So total number was 10. Total digit was 10. So we
Mm.
can use these 10 digits to form any numerical number. Do you
Right.
agree with that? So what I told you, that decimal representation of number has a base of 10. Why
Mm.
base of 10? Because we have 10 digits in our hand to form that number. That's why we call it a decimal form of representation is having a base of 10. Thereafter, I told you that let's say I am talking about some any other language, and there is a 5 digit to represent. So if I want to form any number, I have to only use that 5 digit to form that number. So what will be the base of that system? The base of that system will be 5. Do you agree with me? Do you understand this? Mr. Mishra, I'm
Yeah. Why
uh,
5?
that's I want see. Why 10 here? Please tell me.
Because
Why
0 to
10 here?
9, 0 to
So
9 is 10 digits, so uh, 10 decimal. I mean, 10 decimal will
okay.
be having 10 base.
Let's say this, 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 and this. 1, 2, 3, 4, 5. There is some unique language I have discovered just now. Let's say this, 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 and this. This is a unique language I just not discovered, and this is a 5 unique number in that language. And I have to unique digit. This is a unique digit in that number, and you have to form any number with the help of only these 5 digits. So what will be the base of that representation? 5. Do you understand this? Likewise, here I have 10 digits in my hand to form a decimal number, to form a number. Let's say in some other language, there is a 5 different
Right.
uh, digits, and we have to form the number only with the help of, because Only 5 digits is defined in that language. So
Right.
whatever number you want to form, you have to form only with the help of this 5 digits. That's why what is the base value of that representation of number? That will be 5.
Right.
You got it?
Right.
Now come to the binary representation. In binary representation, we have two values, 0 and 1. So whatever digit we want to form, either 1 million, 2 million, 1 trillion, or whatever number you want to form, you have to use only these two values, 0 and 1. That's why this form of representation has what is the base of this form of representation? What is the base of this form of representation?
2.
Correct. Ruchi, do you caught that my point?
Yes.
So have you understand this base value? What is the meaning of this base value? Fine.
Total number of digits.
Yes, you understand this total number of digits in that in that system of representation is called. If I want to, yeah, this is for your understanding. You understand. So I have moved to the next phase. So come to the next phase. So I'm giving you one example to understand it. Say, there's one number called 1, 4, 6, 7. So I have one number called 1, 1, 5, 6. Which form of representation? Which form of representation this is? Which form of representation this is? I'm asking you people. This is a decimal form of representation having a base of 10. And if I want to convert this into a binary form, I will get this value 1, 0, 0, 1, 1, 1, 0, 0, having this 2. This is equivalent to this. Only the difference is that this is a decimal representation. This is a decimal representation. Decimal representation. Presentation. And this is the decimal representation with base 10. I am getting noise from you people, so you can mute yourself whenever you want to talk. You can unmute and then you can talk. So, and this form of representation is called, and I request Mr. Bhagwan Misra at any point of time, if you are not able to understand anything, just raise the question at that point.
One question. I can't see the lessons.
You can't see the. Oh, when
I'm
you have
only
joined by name.
seeing.
Actually, can you write in the middle because you're writing on the right side, so some of the things are not visible.
Okay, fine. Let me write in the middle. Let me write. So, what was your query, Viney?
Yes, I'm seeing the one that says 2, 3, 4, 5, 2. I think that says test.
No, no. You
That's
have. I'm sharing my whiteboard. So you have to choose the page number. I am on the page number, I think 5. I am on the page number 5. So I think you have to choose the page number 5. On page number 5.
Okay. Yes, yes,
Okay.
yes.
So if you will
Okay.
choose the page number 5, you will get a clear screen.
Yes.
Okay. See, what I am telling that 156. Is it fine now, Mr. Mr.?
Yes.
Okay. I'm asking you, which form of representation is this value? 156.
Decimal.
Fine. This is a decimal form of representation. And what is the base value?
10.
10. Why did you understand why 10 is coming here?
I entered the lesson kind of late.
Okay, fine.
I
So
entered
you
it.
have to rewatch. Okay, you have to rewatch because I'm not going to repeat same thing because I've repeated
Yes, sir.
many times.
Yes, sir.
Fine, fine.
I
Not
will
not
rewatch.
not any. Okay, you can rewatch this session and kindly mute yourself because I'm getting a lot of noise from your end. Whenever you want
Okay.
to talk, you can unmute yourself and then talk. Otherwise, keep yourself in. Fine. So this is 156 with a base 10. And if I want to convert this into a binary form, I will get this 100 111 00. So this is equal to this. Both represents the same value. Only the difference is that this is representing this number in decimal form with a base 10, and this is representing the same number in binary form with a base 2. There is a like proper process of converting this into, I will say, you can search it on the internet and read this because this is a very like a kiddish kind of thing. So I'm not going to explain you that. This is I'm leaving this on your part, or you will do it. It's a very simple process. At this point of time, let's understand this only. If this is equivalent to this value. Only difference in this value and this value is the difference in the representation. This is a decimal representation with a base 10, and this is a binary representation with a base 2. Why binary? Because we are using only two things, two digits, 0 and 1. And the computer understands only this value. So whatever value we are supplying to the our computer, our machine, our laptop, or our program, it will first go in the form of decimal representation, decimal, then it is converted into this binary form, and thereafter it is processed and it returns us the value in the form of binary only. It returns us the value, and thereafter it is again converted into this form or the form which is understandable by us. Even whatever text data or whatever video data or whatever image data, any kind of data that you supply, all will get converted first into this form. There's a whole system of doing that. You don't need to understand all those things. You simply understand this thing. Thereafter, it gets converted into binary form, and thereafter, it is processed by our computer. Hope this is clear to you. Now, let me see what next I will. One problem with this binary representation is that it takes huge amount of space. It takes huge space in memory compared to this, because you can see if you have to represent the same number in binary form, this long you have to do 1, 2, 3, 4, 5, 6, 7, 8. So that's why in the binary form, the same number will take more spaces, and but it is not very complex to process this data by the computer, by our system. That's why although it takes more memory, but it is easier for our computer to understand this form of data and to uh, process this form of data. That's why we use this form of representation. Let me give you one simple example. Okay, well, that programming example, then I will. Okay. Hope you guys understand this. So I am now stop sharing you my white board, and I will be sharing you something else, my desktop. So that I can. Hope my are you guys able to see my screen?
Yes.
What is written in my screen?
Decimal finger eight.
Let me explain you. Let me explain you this thing. See, this is nothing. Suppose I am giving you only two numbers, 0 and 1. Fine. And I'm asking you only to use this number to form any number. Whatever digit I'm going to give you, you have to only suppose, see, we have 10 fingers in our hand, 5 fingers in left hand and 5 fingers in right hand. And we have 10 number of digits in decimal representation. So it's very easy for us to calculate like this. This is 1, this is 2, this is 3, this is 4. This is very intuitive to understand. Let's say God has given you only 2 fingers, 1 finger on the left hand and 1 finger on the right hand, not 10 fingers. And now, if you have to calculate anything, what you will do? You will only count with the help of 2 fingers only. Now, right now, you have 10 fingers. That's why you are counting anything with the help of these 10 fingers. You can simply write 10, 20, like that, and in the like that. But let's say you have only 2 numbers, God 0 and 1. 2 fingers. First, understand 2 fingers. So you will do all your calculations only with the help of 2 fingers. Now I'm saying you, let's take only, I'm giving you only 2 digits, this 0 and this 1. And I want you to calculate whatever number I am giving you with the help of its value with the help of these 2 numbers. So first understand this. This is decimal. This is my finger. This is 8, 4, 2, 1 and binary. This is the binary representation. 1 means This can also be written as 2 power 0. This 2 means 2 power 1. This 4 means 2 power 2. And this 8 means 2 power 3. Hope you understand this. Means if you have now I have 0 and I want to convert this into binary form. This is a decimal form and I want to convert this into the binary form. 0, how many times this 1 will come? 0 times. This will also come 0 times. This will also come 0 times. This will also come. We will get the same. The binary, the decimal representation and the binary representation of 0 is same, equivalent. This is the decimal equivalent of decimal representation of 0, and this is the binary representation. Now let's say 1 finger. This 1 is represented in decimal like this, and I want to represent this one in the form of binary. I have only two things, 0 and 1. So how many ones will come to represent this? This one. All this will be 0. So I have 1, 2. This is the binary representation of this one. Now let's say this is 2. So for representing 2, how many 0, how many 2's will come? How many 1's will come? 2 raised to the power 0 means 1. 2 raised to the power 0 will give me 1. 2 raised to the power 1 will give me 2's. 2 raised to the power 2 will give me 4. And 2 raised to the power 3 will give me 8. So this 2, I have to represent this 2 in form of binary. So let's take this. How many times 1 will come? 0 times. How many times this 2 will come? 1 time. This 2 will come how many times? 1 time. This will come 0 times. This will come 0 times. Finally, 1 0 to the base 2 is our representation. This is our binary representation. Let's take this. Let's take this 3. 3 is the decimal representation, and I have only 2 digits to take. So how many times this 1 will come?
1.
1 time. How many times 2 will come?
1.
1 time. This 2 plus 1 will become 3. And what will be the binary representation? 1 1 to the base 2. This 1 to the base 2. You don't have to remember this. This is just why I'm telling you all these stories, so that you should know how actually the things works inside.
Right.
That's why. Otherwise, these things are not part of these are not part of the Python. It is a very basic thing.
Do we need to remember this, or we can
No, you don't need to just understand this, so
Yeah.
that you can have a basic, this is a basic thing. You just have a basic understanding how the things will go. No one is going to ask you this question. This is such a basic thing.
Okay.
You have to just understand. And one more thing, don't try to remember anything. Whatever we are going to learn, don't ever try to learn these things. Just try to understand and find some time to revise the things. Don't never try to remember these. Because what I believe personally, if you try to remember the things, it will be very active task for you. If you just do things on a regular basis, it will slowly and progressively, it will come to your consciousness. And you can get a hold of it over a period of time. So don't try to remember these things. Just do some practice. just revise sometimes, and then that's fine. Similarly, this 4 is represented at how many times 1 will come? 0 times. How many times 2 will come? 0 times. How many times 4 will come? 1 time. 2 to 2 are 4. So I am getting 1, 0, 0. This is a binary equivalent of 4. I'm just helping you to understand how I'm converting a decimal form into a binary form. This is one way of converting. So this is 5. Now let's say how you will convert it. How many times 1 will come? 1. How many times 2 will come? 0. How many times 4 will come? 1. So we will get 1, 0, 1, 1, 0, 1. This is a binary. Likewise, all these things. Hope you get an understanding of this thing. Fine. Is there any doubt? Because I'm not going to open this sheet again. If you have any doubt, you can ask.
No, it's it.
Fine. So let's move to something else. So what here I'm trying to explain, this is one character. This is the symbol of euro. This is U, this is R, and this is O. Even you can convert when you enter any text value. How it works, that it first get converted into decimal code point. The decimal I have explained to you earlier. So this is the this symbol, this euro symbol has a decimal equivalent value of this. This U has a decimal equivalent value of this. This R has a decimal equivalent value of this, and this O has a decimal equivalent value of this. Likewise, whatever character is there, every character has a decimal code point value. And if I want to send this euro dollar to our computer, if I want to give him the information of this euro dollar, first this euro dollar will get converted into this decimal code point. After that, from this decimal code point, it will get converted into binary code point. And this representation, my computer will be able to understand and process. Hope you understood this.
Yes.
So because I have prepared today only, I have collected it from various sources so that I will make you understand all these things. So now let's, I'm sharing you. From today onward, you will not face any difficulty while understanding. Now, how this expression A has a binary value of this and has a decimal value of this. This expression B has a binary value of this and a decimal value of this. Now I am performing A and B, this operation, A and B. So what this operation says? For A and B, it will represent this is 0, this is 0, So 0, 0, what I will get? I will get 0, 0. I will get this 0. Why? Because this is also 0, this is also 0. That's why I will get this. Now this is 0, this is 0. I am getting 0. This is 1. This is also 1. So I am getting 1. Now this is 1, this is 0. This time what I will get? I will get 0. Because for the value to be true, because in Python, 1 means true and 0 means false. You remember this. 1 always signifies 0, 1, and 0 always signifies false. So this is kind of, this is false and this is true. But in end form of representation, this value will be true only when both the values will be true. Since one is false, one is true, that's why I am getting this as 0. 0 means false. This same likewise, 1, 1, I am getting this 1 and 1 as 1. Since here it is 0, here it is 0, that's why I will be getting here 0 and 0. So this is the, after performing this operation, AND operation on this binary value, I am getting this binary value. And when you convert this binary value into decimal value, you will get this. Is this clear to you or not? Mr. Misra, I am asking you.
No,
No? Ruchi?
because
Tell me what is your issue. Ruchi, is this clear to you or not?
Yeah, yeah.
Fine. Let me explain. True, true, false, false, true, false, false, true. That's fine. If you apply the AND operation here, what you will get? True and true, what will you get? True or false?
true,
What you will get here?
false,
False.
What you will get here?
False.
false,
What you will get here?
false.
False.
You understood this? No.
Yes.
At the place of true, replace it by 1. Because I have told you in Python or in any programming language, 1 represents true and 0 represents
False.
False.
false. So wherever you are getting true, replace it by 1. Wherever it is false, replace it by 0. True 1, false 0. This is false 0, 1. Now say 1, 1, what you will get? 1, 1 means true, true. What you will get? True or false?
One.
One.
1. 0, 0, what you will get?
Zero.
Zero.
1, 0, what you will get?
Zero.
One.
Zero.
0. I am performing AND operation. And will perform the task only when both are true. Here one is true and other is false. That's why it will give you the value false, 0. What? And here,
Zero.
Zero.
Mr. Ji, 0.
Zero. Zero.
This and this are same. There is no difference between this thing and this thing. Will you able to understand this?
Yes.
Fine. Now, See, same thing I am doing. This 0 and 0 will give you what? This 0.
0.
This 0 and 0 will give you what?
0.
This 0. This 1 and 1 will give you what?
1.
This 1 and 0 will give you what?
0.
0.
This 0, this 1 and 1 will give you this one.
1.
1.
So after this expression has a binary value of this, and this B has a binary value of this. When you perform AND operation on this binary value, you will get this binary value.
Right.
Are you getting? Is this fine for you? And
Right.
when you convert this binary value into decimal value, you will get this. Is this fine for you or not? No. Hope you understand this.
No,
Yes.
this up till 101002 is okay. But how it is getting converted to 20 base 10?
See, just like there is a way to convert it. I have in the last sheet, I have explained you how you can convert any uh, decimal value into binary value. I have explained you. So there is a way to convert it. Don't go into that. Just understand, because it's a calculation, something like that. If you sit and calculate it, you will get this value simply. I have explained you in the earlier sheet. I have already explained you how to convert the binary value. Hope I remember. I think you shall remember this. I have explained you in the first sheet. Let me. Okay. I explained this thing to you now. Hope you remember this. This is a decimal. You have to convert this into binary, and there is a way to convert it. You can convert any decimal number into the binary form with the help of this. So I have already explained you this thing.
Yes.
Here I am not explaining you the same thing. What I am explaining you here. So if you convert this thing, if you convert this value into a decimal representation with the help of the chart that I have already explained you in the earlier, you will get this.
Okay. Okay.
When you convert this binary value into decimal value, you will get this. When you convert this binary value into decimal value, you will get this. And when you convert this binary value into decimal value, you will get this. Simple.
Okay.
So let's move to something else. Explain this something more, because I have a lot of things to explain you today. I think that was C. Here, last time here it is a bitwise. This is called OR operator. Bitwise OR. This is a symbolic representation of OR. OR is represented with this. So same thing is here. A has binary value this, B has binary value this, decimal value this, and I am performing an OR operation on A and B. So this 0 and 0 will give me what?
0.
0. This is not AND operation. This is OR. If any one of the value will be true, the value will be true. This 0, 0 will give me again 0.
0.
This 1, 1 will give me
1.
1. This 1, 0 will give me
1.
1. This 1, 1 will again give me 1.
1.
This 0, 1 will give me
1.
1. This 0, and here there is nothing to consider it as a 0. So 0, 0 will again give me 0, 1, 0 will again give me
1.
So this is the value after performing a bitwise OR. Hope you understand. See,
Right.
why I am focusing you on this, why this is called bitwise, because here the OR operation and AND operation is getting performed at the binary level, at the binary value. And whatever value I am getting, I am performing this OR operation and AND operation at the binary level, on the binary value. That's why it is called bitwise operation, bitwise OR. That's why it is called bitwise AND. And whatever bit binary value I am getting, and the computer will convert this into this decimal value. And I'm getting this. Hope you understand this. This is, see, this is how internally our computer CPU works during the time of processing the data. So
Okay.
now let's see another thing. Let me give you some other example. So, okay. This is called XOR. 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 How this works? Let me explain you how this works. XOR operator works like that. If I suppose this 0, 0 will give you 0 value. This 0, 0 will again give you 0 value. This 1, 1 will give you, whenever both the value is true, this is true, it will give you false. It will give you 0. XOR operator works like that. Whenever this two value is true, you will get 0. Whenever this two value is false, we will get 1. I suppose this is how the XOR operator works. Let me check it. Yes, I was telling you correctly. This is how this XOR bit works. If any one of the value is 1, it will give you 1. Otherwise, it will give you 0. So it is like, this is right. This 1 and 0 will give you 1. If any one of the value is true, it will give you true. But if both the value will be true, it will give you false. So this will give you 0. This will again give you 1. This will again give you 0. This will again give you 1. This is how XOR operators works. Do you understand this?
Yes.
Ruchi,
Yes.
please explain. Please explain.
Operator.
See, I'm telling you,
When
understand
we
this.
get both true, it will give 0. When we get both false, it will give 1. Then one of the When one is
Then
true, another is
what is
false.
important in XOR is when both is 1, it will give you 0.
It will be 0.
When both will be true, it will give you 0.
And
Otherwise,
both,
if one
yes.
is true, one is false, it will give you true. If
Hmm.
both is true, it will give you false.
Hmm.
Fine. If both is 0, then also you will get 0. Only you have to keep in mind if one, if this is 1 and this is 1, if both is true, in that case you will get the opposite of it.
Okay.
XOR is also called not OR. I think XOR is also called not OR because you are doing OR first, then you are doing OR, and then you are doing not on it. That's why it is called not OR. I think I suppose this is how it is. Hope you understood this. Now let's move to next.
Yes.
Next thing. What is the next thing? See this. This is called which operator is this? Which bit operator is this?
XOR.
Yes, this is the XOR. Fine, this is the XOR. So let's understand this here. This 0, 0 is giving me 0. This 0, 0 is giving me this 0. This 1, 1 will giving me this 0. I have explained you this in the last sheet, I suppose. Whenever you have a true value, it will give you false. This is the important thing to remember. I have 1 here, I have 1 here, so I am getting 0. I have 1 here, I am 0 here, so I am getting 1 here. I have 1 here, I have 1 here, so I am getting 0 here. I have 0 here, 1 here, so I am getting 1 here. I have 0 here, nothing. That means consider it as 0, 0, 0, 0. I have 0 here, 1, 0. It will give me 1. So, do you understand how this is working? How XOR operator is working? This is called XOR. Yes. Ruchi?
Yes, I got it.
Here,
Sanjay?
false is also false.
Yes, false, false.
No.
Yes. False, false.
False. This is also false.
False, false is false. See, this is how the XOR operator works. There is nothing rocket science. Why this is, even I don't know. This is how the makers of the computer language has designed it. That's why it is. This is how XOR operator works. That's it. Hope you understand.
Yeah.
Shall I move ahead?
Yes.
So
Actually, yeah, true.
ah, please tell. Please
True
suggest
is
something.
true. True is true, but it is XOR is not OR. Okay,
Okay.
so it will be false. Again, false is true, but XOR is not OR. So it will be false.
I like this interpretation. I suppose maybe true.
I don't know, man. That is the way I understand. I don't know what is your explanation.
No, I suppose you are right. I suppose you are right. Because XOR, I suppose, if you can Google search, XOR is exclusive OR. No, XOR is not OR, not exclusive OR call. It is called exclusive OR. That means maybe you can Google search and see if your explanation is correct. And even when you come to the next time, please tell me, is this whatever you are telling is correct or not? And I will also do the Google search and see. As far as I remember, or not or exclusive, or I am a little bit confused. See, this is oh, this is called not. In the during the at starting of the session, I have told you unary operator. So unary, this is an example of unary operator. You are performing the operation only on one single operator. Before this, whatever operation you are performing the operation on two operands, A and B. A or B. But here you are performing the operation on a single operand, A. So A has a binary value of this, and you are negating this. So 0 get negated, what value you will get? 1. 0 get negated, 1. 1 get negated, 0. 1 will become 0. 1 will become 0. 0 will become 1. 0 will become 1. And 1 will become 0. Yeah. So this is the value I will get. I suppose this is clear to you. There's nothing new in this thing. So let's move to something. This is called bitwise Leftshift. In this, what this is called Leftshift. Leftshift. So what this is doing, A has a binary value of this, and since it is asking to shift A less than symbol is called left. It is asking A to shift by 1. So see, this is getting shifted one place. 100,111 is shifting one place here to the left, and the void is getting filled by C. So whatever the value this is a binary value, and this is a decimal representation. When this bit is shifted one by one place to the left, my value is getting doubled. Here is the 39. What value I am getting? 2 times 39. 2 into 39. Are you clear on this? Mr. Ji, please. Are you getting clear on this?
Once again.
Ruchi, is this clear to you?
No.
Fine. Please understand this. This is called left shift. This is an expression A which has this binary value 1001111 to the base 2, and its decimal value is this. Now I am asking A to shift its place by 1. So if I put a blank here, let's put a blank. It is a blank here. So all this value is shifting one place to the left. 111, this 111, 100, 100, 111 is shifting one value to its left, because this is saying A left shift 1, or one value to the left. It is asking A to shift your value, one value to your left. So it is shifting its value to left, one value to its left. So when this value will get shifted to left, void will get created. 1001111, 1001111. See, when this value will get shifted to left, what I will get? 10011.
Okay.
1. So here a void will create, one value it is. I am filling this void by 0.
Right.
So what value I am getting? 1001110. When you convert this binary value into decimal value, you will see this is 2 times this decimal value. 39 is, if you multiply 39 into 2, you will get 17. So when you are shifting your binary value, one value to the left, what you are doing, you are actually doing 2 raised to the power 1. Now see this. When you are shifting this binary, your binary value 2 place to the left, here what you have to do? A 1001111. 1001111. This is the same. You have shifted this value. Let's represent this by blank. You have shifted all this value to here. So 2 space will get 2 void. This 2 empty space will get created here. I am filling that empty space with 2 zeros. This 0 and this 0. And when I am representing this binary value into the decimal form, I am getting this. And this, this is 2 times 39 to power 2 raised to the power 2. If you multiply 39 into 2 power 2, that means 4, you will get 156. That means how much, whatever will be the, this will, if you are shifting A one place to the left, you are basically multiplying A, the decimal value of A, with 2 raised to the power 1. If you are shifting this A 2 place to the left, you are basically multiplying your number with 2 raised to the power 2. Same way, if you are shifting this A to the 3 place to the left, you are basically multiplying this with 2 raised to the power 2. If you shift this, you have to place this 3 on the right, and if you convert this into decimal value, you will get this, which is 2 raised to the power 3. That means 39 multiplied by 2 raised to the power 3, that is 8. Is this clear to you or not? Please tell me now.
Yes.
Ruchi?
Yes. Yes.
Because see, I'm putting all my energy, all my efforts to make you understand. So I want that you should understand, because I have collected all these things from different resources just to make you understand how the things is working. From today onward, I suppose you will not get confused in these operators. And if you ever get confused, you can definitely refer to my recorded video and we'll get the clear. Now let's come to understand something more. So what's left? This is bitwise right. It is opposite of the bitwise left. This is called bitwise. Left shift, this is called right shift. Bitwise. I think, Mr. Misra, you are confused on this in the morning. Why? Because you do not you don't have the understanding of the background of these things. So that's why what I have done. First, I have explained you the background. Then after I'm coming to this, because
Right.
if in the morning, why I have not explained you, because to explain this thing and make you understand, first thing is to explain the background of this thing.
Right. Right.
Then only you will be able to understand. If simply if I will make you understand, you will not be able to understand simply. That's why I have ignored your morning yet and told you that we can take it in some other class, because it takes time. So this is called the right shift. Simply, here what we are doing, this is a binary representation. And here what we are doing, we are simply, there we are shifting to left, here we are shifting to right. 2 places to the right. 1 places to the right, so I've shifted it to right. Same thing, 2 places to the right, I've shifted this to right. And here I am getting the opposite. I will be getting something like that, 1 by something n by 2 raised to the power n, something like that. You can see it. It is something like that. In the previous thing, it was like 2 raised to power 1, 2 raised to power 2, but here it is something like that. Let me check it on the internet. Bitwise. Let me check it so that I can.
But this is not matching. 78 into 2 will be 156. It is 157.
That's why I'm telling you, it is this 2 raised to the power. This is not. It is like a by 2 raised to the power n.
Even 19 into 2 is 38.
Please.
It's coming 39.
2 by actual thing is that 2 raised to the power. What is n? What is the value of a? A is this 157. 2 raised to the power n is
2 raised to the power 1.
first n is 1. So if you multiply this, divide this, you will get 2 sevens are 40, carry 1,
Yes.
2 8s are
7.
60. You will get this.
So after decimal, it is not okay.
So it's opposite, na? That's why you are using here this thing. A by 2 raised to the power n. A by
Right.
2 raised to the power n. It is just here we in the right shift, we are doing this. In the left shift, we are multiplying this 2 raised to power by 2 raised to power n. And in the right, see, we are doing nothing. In the left shift, we are multiplying by 2 raised to the power 1. In the left shift, we are dividing by 2 raised to the power 1. Same is true here. If you divide this by 2 raised to power 2, you will get this 157. Let's divide 157 by 2 raised to power 2. What is 2 raised to power 2? 4. So how much value you will get? 4 3 is 12. 3, 4, 9 yeah, 36. So you are getting 39. Same is true here. If you divide 157 by 2 raised to the power 3, what is 2 raised to the power 3? 8. 8 ones are 8. Then you have 7. 8 9 is 72. You will get 1. Hope this is clear to you.
Right.
Yes.
Ruchi, is this clear to you?
Yes. Yes. Yes.
So let me explain you some more thing, because still it's, see how much time it takes to explain this simple thing. So let me explain you first. Clear my. So I can see this. This is about this. So now let me explain this. What we said. Let me explain a few more things here. Are you able to see my screen?
Yes.
See. Hope you understand this loop. For character in Euro, this is a string. And we are printing this ORD. What this ORD will give me? This ORD will give me the decimal representation of this individual number. Let's say if you do not write this, what you will get? If you do not write this, what you will get? Euro. I think this, you can understand this, but I want what is the decimal value of this euro, this symbol, U symbol, R symbol. So that's why I am attaching ORD here. Now, if I do the same thing, I will get character wise its decimal representation. if you want to understand what is the bit length of any decimal representation, so simply what you can do, I am taking this 42. It must have some uh, binary value, and I want to understand what is the length of the binary value. So this is how, if we can do this, we can get the length. You can take the length of any value. Let's take this value, and if you can do this, so this is the length of this value. One very important question that I want to discuss with you. See what you will get as output. Tell me, both of you. I want an answer from both of you. Then I perform this operation. What shall I get? You guys become quite silent. I'm not getting any answer.
2.
Are you guys there or sleeping? 2? What,
2,
Ruchi?
2.
What,
2 is
Ruchi? You... So, fine, you got your answer. Now, please wait. So, Ruchi, you...
I'm confused. I'm not getting it.
Okay, let's run it. Let's run this. I did it. Why I'm getting to here? Let's take another value, another thing. I'm getting this. Why I'm getting this? Let's understand this. Mr. Sankar Mishra, will you please explain why I'm getting this? Because you have done it correctly. So may I know the logic you have applied?
0 or Anup, then it is coming 0, Anup. If it is 1 plus 1, 2 or Anup, then it is coming 2.
Yes. So why this is happening?
Because 1 is true and 0 is false.
Because
1 minus 1 is 0, which is false.
1 minus 1 is 0, which is false. Okay, 1 minus 1 is 0, which is false. Okay, and here it is Anup, that's why you are getting Anup. And 1 plus 1 is true. So you are getting true. So 1 plus 1 is true. Will you understand this? Or shall I explain you?
Is this the right explanation?
Yes, this is a right explanation. Actually, what is happening here? That first it is
But
inside this bracket.
I could not understand line 3 when order print ORD character. ORD means?
So why you have not asked? Well, let's first understand it, then we will go to that. Let's first finish this, then we will move to this. See, so what is happening here? This 1 plus 1 is, it is like first thing, 1 is like true, this is like, this one is like true, and this odd operation is there, so true is true. So this whole expression is coming out to be true, and here it is some other expression. So it is returning me the true value, this 1 plus 1 finally. And after that, I am getting 1 plus 1. This 1 minus 1, 1 is true, and this 1 minus 1, I will be getting false, something like that. Or Anu, so since it is false, I am getting this. This is how I suppose it's. Otherwise, it's a task for you to understand this and explain me in the next session. Now, I suppose you do not find it difficult to understand this. Let me first explain you this thing. What is your problem here in this order? Will you please explain? Are you there? Are you there?
Yes, yes.
What was your issue here? This particular? See, order is simply doing what? It is simply giving me the decimal value of a character. If I do not put ORD here and simply run this, I will, as I have already taught you this, how the for loop is working. This is first printing this symbol, this euro symbol, then U, then R, then U. But if I will say order this, then it will give me the decimal representation of this value. What will be the decimal representation of this value? So this is the decimal representation. So what you understood, why I have explained you, to make you understand every text.
Where we will write this epsilon E in the typeboard.
Let's forget this. Say something else. R. Let's take Ruro.
Yeah. Now it's okay because I was getting a different value.
Fine.
I was
You can
typing E.
you can check for any value. It is not true. Let's take this.
I was
Is
typing
this fine
E.
for you?
I was typing E, so it was coming
Yeah.
101.
Fine. That's okay. Because if you will type some other value, apart from what I have typed here, you will definitely get a different. The only thing is that, are you able to understand this or not?
Yes, this is giving the decimal value.
So fine, it's fine. So we have understood this left shift, right shift. So now I suppose you don't face any problem understanding this. What you guys were having in the morning. 5. What is this shift called? Right shift 1. So I am getting this. If I do 5, right shift 2, I will get this. If I do 5, right shift 3, I will get this. If I do something else, let's say 50, left shift 2, I will get So you already understood the concept behind how this is working, but in the programming you don't have to do all this because program is there to make a calculation for you. You simply understand the concept behind this. Although this thing you are not going to use these things maybe sometimes, but still it's good to understand. One important thing, whatever I have taught you, I will give you the complete theory that I have explained you, so that you will be able to understand this. What is floor means? What floor means? Floor means it will either shift to one extreme or shift to other extreme. Suppose if I am getting some value 5.63, its floor value will be 6. If I am getting value 5.23, its floor value will be floor value. No, this is not correct. I suppose this is floor value means it will shift its value to its nearest integer. That it means it will shift its value to its nearest integer. What is the nearest integer of this? 6 is the nearest integer. So it will shift 6 its value. If let's say 5.23 is the value. So what is the nearest integer to 5.23? Is 6 is the nearest integer or 5 is the? 5 is the nearest integer. So it will shift its value to 5. So whenever an odd number, because I have explained you in the bitwise Rightshift, you have to do this by 2 raised to the power n. See, 2 raised to the power. Now, if a is some value which is completely divisible by this number, then you will get an absolute integer value. If in case this is not divisible by this, then you will get some decimal value. So in that case, what it will to get rid of it, the Rightshift operator automatically floats the result. Floats the result, what it means? Floats the result means it will shift the result to the nearest integer. Whatever integer value I will get, it will shift it to the nearest integer. That means by the floating. Float. Hope you understood this. So fine. I am stopping sharing my screen. Okay, this was a very long session, I suppose, and you guys get bored. But hope you have enjoyed this session. Kindly give me the feedback of this session because I suppose this session is approximately for last for 2 hours without any break. I enjoyed this entire session. Hope you guys too have enjoyed this session.
Yeah,
Is there any feedback? Is there anything that you would like to share?
It was a good session.
Ruchi, can you say a word for this session?
Interesting one.
Is it interesting?
Yeah.
Fine. So you have to wait for 2 minutes. I am stopping the recording. So fine, guys, whosoever are watching my video on YouTube channel, I request you to join my Telegram group and enjoy the free live classes at no cost at all. I am going to teach statistics, machine learning, deep learning, and lot of things in the coming days. So be ready for it. Don't forget to subscribe this channel and press the notification button. And in the descriptions of this video, I will attach the entire sheets that I have discussed during the class. And so thanks for coming. Have a good day. Bye.